All right, so let us start this video with our first category. So we are going to cover traversal, graph traversal, and we will talk about the BFS and DFS. And so obviously BFS and DFS, a lot of videos are out there, right? But because we are starting this one, so we'll start with the basic. This is the basic in graphs. In BFS and DFS, what we will try to do is we'll try to come up with a template so that you don't need to reinvent the wheel, or do not just keep it as that I know BFS and DFS, hence I will derive the algorithm in interview. Rather, we'll keep a template ready with us and we'll try to implement the same template in every question. So this will be one takeaway. If you already know BFS and DFS, this can be a takeaway for you, that you can have a template ready for you. Let's start with BFS, breadth first search. So normally whenever you are asked to find a shortest distance, right, that is where and obviously if you have to do a traversal, BFS will come in picture. This is like a known fact, but let us just see what exactly will happen when you do a breadth first search. So this is a level order traversal. By that we mean, if we are starting our traversal, let's suppose if A is our source or root node, right, in a graph given to us, or we identified it as a root node from where we are starting our algorithm. Then the next level is whichever nodes are directly connected with A. So in this case, B and C. So let's directly start with what will happen in tree traversal, in graph traversal when you are doing breadth first. So you are at A, we will directly mark it as that this is my visited node. So we'll change, you can say, color of it. Right now I'm doing it double circle, that this is traveled. And from source, I will say the distance from source is 0 of this one. Now all the neighbors of this A, I will add them into a queue, because BFS we use queue. No need to reinvent the wheel, we'll simply learn that algorithm. If we are adding them into the queue, you can say that it is already added or visited. Okay, so I'm adding it into the queue, all the neighbors, so these two added. Now I will pop one, any of it. So when I am adding it into the queue, I will simply add what is the distance of it. So whatever was the distance of parent of this plus 1, so this will be 1, and C will also be 1. Now from my queue, let's suppose here is a queue, I had A, right? A is already popped, hence B and C were pushed into the queue. Now I will pop B. So when I'm popping B, what are the neighbors of B in this case? So I'm having only one neighbor, which is D. So I'll push that into queue. I will mark this as visited, and I will update the distance to, in starting the distance is infinite, you can imagine, that because we don't know the path. So it will be update to 1 plus 1, which will be 2. Then after that, there's nothing else to explore from B. So we'll come back, we'll pop the next thing, which is C in our queue. So C is popped. From C, we can go to E, only one. We will push that into our queue and mark it as visited, update the distance. So this was 1, so 1 plus 1, it will also be 2, right? And then this is already pushed in our queue. and C is explode. There is nothing else. We cannot go anywhere else. Now, next is we will pop D. Now from here, interestingly, first we can go to A. It's just that VA is already added into visited. So we can imagine that visited is a set. It can be a normal array, or set is the simplest thing to take here actually. So if that is already visited, we will not do anything. So hence you can say in that loop, nothing will happen. The next neighbor to D is E. That is also already visited because we marked it already visited. So nothing will happen there as well. So this is simply popped out, nothing happened. Then next E pops out. E will add first neighbor of E is D, right? But because that is already marked as visited, so nothing will happen. And the next neighbor of E is F, and for F the distance is infinite, so we'll update it 2 plus 1, so it will become 3, and we will mark it as visited. We'll push it into the queue. Lastly, now E is done, so F will be popped out, and there is no neighbor to F into our graph, hence nothing will happen into that loop, and we are kind of done. So whenever we are doing a pop, at that time you can say we are processing the node. So if we just have to push them into an answer array, we will simply push. So this will be our order in which we pushed it into in the order in which we popped from this particular queue. That will be our order. So this is breadth first search, which is just the traversal. Now let's get the algorithm of it. All right. So this is, you can say, the base template of BFS, which we can follow in every question wherever we need to write BFS. I am doing it in Python. Recently I would say I picked Python because in interviews that saves a lot of time. Normally I'm a C# and Node developer, which I use in my professional projects. But I realized that writing the code in C# in interview takes a lot of time, especially when I need to use queue or heap, right? So yeah, I picked Python. Less number of lines, no other reason. But language is irrelevant, right? So first thing first, we need some supporting data structure for us. So like I said, we will use queue in breadth first search. So I simply took a queue. This is the way to define a queue in Python. Then we created a visited set. Right, it can simply be an array as well if your nodes are like numbered like 1 2 3 4. So in that array itself you can mark it as 1. By default value is 0, so if you are visiting it, you will replace it with 1, right? And that can also be act as a set, but yeah, better use a set. Now, like we said, by default, if we know our root node, we will push that into our queue. That is what I did here. First, we are pushing it into our queue. After that, we also mark it as that we already visited it. Why? Because it's possible, like we were doing here, that D will try to push A again, right? So you have to mark it as this is already added. You can call it visited, seen, whatever, right? But the thing is that you already pushed it into the queue. We need to mark it. So for that, we are using this visited set. Now this is the crux, this loop. What you need to do is on every node, you need to run that while loop. So while my queue is not empty, is simply I will pop whatever is there in the front of it. So I will pop, let's call it a node. Now for all my neighbors, so these two lines you can ignore for now, this is the processing, right? But all my neighbors, like in case of A, those were like B and C, I need to push. So all the neighbors which I'm getting from my graph, it mostly will be an adjacency list, that what are my adjacent neighbors, I should be able to get it easily via this. It should give me an array. So for all my neighbors, I'm simply trying to push them into the queue. And if I'm pushing them into the queue, I will also mark them as visited, which we did here. And to do that, that is where we are just doing a check. If it is not already pushed, then push it. This is a very basic template for BFS. Let's not try to complicate it in the beginning. When we'll move ahead with a lot of questions, we will obviously do some tweaks here and there to detect the cycle, to just process, right? To process without knowing the start node as well, without knowing the root as well. So a lot of tweaks will happen, but here intention is to have a template which we can reuse so that we can practice question. There are a lot of videos, I would say MIT, IIT videos, lectures you will already find freely available to you, and no other lecture or video can even match it. But here we are looking for something so that we can practice a lot of questions easily and learn just by practicing, just by doing it. Okay, so we'll continue with this template. We'll try to solve some questions which we identified earlier, and let's go ahead with that. All right, let's see our first question. So we have identified 3 questions which we will do with graph traversal. This is the first one. This is obviously implicit graph. Graph is not given, a matrix is given, but we'll try to apply the same algorithm here, and it's good actually that we will be able to cover this as well. Matrix question. Now, so we are given a grid, and where 1 is considered as land and 0 is water, and whatever is around this grid is basically water. We just need to find out how many number of islands. Actually, a number of islands is a different question, but here is maximum area of island. So there are different islands, obviously, whichever is having like max a number of ones is simply we need to figure out. Now the only thing we need to do here is we need to go to every node. Like in this case, we will go to this, we'll say this is water, we will not do any traversal. Then when we'll reach here, we'll try to do a depth first search or breadth first search, but because we are on topic of breadth first search, we will use the same algorithm which we did here. We will do breadth first search using this as my root node, and it should give me how many total nodes this breadth first search explored. If it will give me, I will simply check if this is the maximum out of all the breadth first search which I will do. So that is, you can say, the crux of it. When we will do this one, so obviously there is no neighbor, so you will get an answer like 1. And when I will reach till here, it will do breadth first search with all the neighbors, so it should explore all of this and return 4 as answer. Same way, when I will come till here, it should return 5, and 5 I think 6 is my maximum answer, which is this one. Okay, the only so one is because explicitly a root node is not given, that means we will try. So first we'll do a breadth first search from this particular cell here, right? And when I will move forward into the matrix, I will again try to do breadth first search from here. In that case, that is where our visited set, which we did here, right, will be very useful, because we will simply check if this is already traveled. That means I already did breadth first search from some other root node, hence it's not required to do it again. And that way we will not process nodes again and again. We will not even go inside. Okay, so now coming back, how we are going to cover this, we will simply try to do, we will do a for loop on all my cell in matrix. This is, I'm trying to say, is kind of outline. So on all the cells, I will simply check if cell is visited, then don't do anything. Do nothing. Else, this was my if, right? Else, what I need to do is from that cell, you simply call your BFS algorithm with on that cell. Okay, BFS itself will do, mark it as visited and all those things. And this is supposed to return me number of nodes. So let's call it just a number of nodes. And after it is easy. I'll simply check if, let's suppose I'm having in my answer variable. So I'll say answer is equals to whatever is maximum of my answer if I already calculated something, and this number. That will be everything if I'm already having my BFS algorithm with me. So I just need to call it. Some changes I'll do into this BFS. Now what those changes will be, that I should keep this visited as global, because if I will create this, visited graph inside, then basically I will reset it. So in beginning itself here, I should be able to check if my cell is already visited or not, right? So in that case, I'll keep this as global. That means I'll define it into whoever is caller of my BFS. That is where I'll define this set. Other than this, some changes will be here in the process. Basically, I don't need to print anything. I simply need to return an answer. So here somewhere I can define like numbers which I need to return, which is 0, or it can be 1 in the beginning because I already inserted the parent. And this is where I can do number plus 1, either here or here. So if I'm doing it here, then I will start it with 0, and I can simply do number plus 1. And ultimately, you just need to return this number. That's it. Okay. And we'll talk about the complexity of it. But first, let's just try to copy paste this code and see if we are covering everything or not. All right. Let's come on LeetCode and try to solve it. So I copy pasted the same code which we already had. Some changes I said that firstly I will not define it here. I will imagine that this is an object. So this is the property of my class, solution class. So I'm simply using it here. So I'll add start, basically my node in this one. So this is the one change which we said we'll have. Another one is I do not need to print anything. So I'll keep the comment as it is. I'll say if my number which I'm looking for is 0 in the beginning. So here I will do my number plus 1. And in the end, I should return. This is what I'm looking for. This is the main question which they gave. One more thing I should give is basically we will define whenever we are working on metrics, right? So that you don't need to check up and down, means how to travel. Have I would say a standard array already created which you can reuse in metrics question. So in case of 4 directional, because this is 4 directional is said in the question, so I'll have like they said here that it can only go, it will consider up, right, left, down as neighbors, but not diagonally. Like these two are not considered as neighbors. Okay, whenever this is the case, so because like I said, we should always have template. We should not do things randomly. It's not like today I'm writing a code where I'm considering my left first and then up and then right, and tomorrow when I'm writing the code, I'm writing like up first. So always have one template. That will help you to make less mistakes when you are working on questions. So keep those things as static, do not keep them as variable. So I'm already having this array created. What I do is normally I explore up first. If this is my root node, so I'll go in the matrix up first, and because this is 4 directional, then right, then down, and then left. Same way, if it would have been 8 directional, then I will go again clockwise, up, then this corner, then right, then this corner, likewise. So this is my array I already defined. Like I said, visited, I'll keep a set define here, and so I'll call it self. By adding just self in Python means you are adding this as a property of the class. So we said 2-3 things, that for every cell, so I'll call it like x comma y in my grid. So first thing I think I will have for x in length of my grid, which will give first row, which is 0, then next row, right, likewise. And then y in length of grid x, whatever is the length of the row. It should be the same number, but it's this will be an integer, so I'll call it as run on the range of it. So this is supposed to give me 0, 1, 2, 3, 4, like that. Okay, so we said one thing here, if x comma y not in visited, then only do this. And what do we mean by that? So we can actually check a tuple is there in the visited or not, in the set or not. So this is simply we can check in Python, and normally we can have a visited as a 2D array as well, but yeah, it doesn't matter. We are not going on language specific. So if this is not visited, we said that my algorithm should give me a number, right? So I'll say number is equals to, I will call my algorithm, which is BFS, and in this I am supposed to pass the root node. Now my root node is actually x comma y, number of cell, and second thing I am passing is my graph, which is a grid given to me. in this case, right? So I'll make these small changes there as well. Now because I need an answer, so I'll say in beginning answer is 0 if there is nothing, right? So 0 will be the maximum size, and whatever is bigger between this answer and num will be replaced, and ultimately I will return the answer. Now two changes. In place of start, I'm getting an x comma y, and graph is a grid. So here I will add x comma y into my visited set, and after that same thing should happen here as well. In queue I will add it as array. So in graph x comma y, I'll try to get x comma y will be popped from the queue. So these are the small changes which I need to do. Same thing when I'm saying neighbor, it should give me, okay. So now one change is, like I said, we have this direction array, so I can use it in my loop. So I'll simply replace this simple loop in direction. All right. So for if I need to go up from any cell, I just need to minus row, which is my this one -1, and no change into the column. So 0 should be added into whatever. If this is x and y, so I should do x -1, and I should do y plus 0. So that is what I'm doing here. Whatever is x and y here, I am simply doing x plus dx from that direction array, and y plus dy from my direction array again, and I'm simply placing them into new x and new y. Now obviously I need to do some checks. If this new x is between my rows and 0, and same thing with the column 1. One more thing I need to check here is, if all of this is checked, then my graph at new x and new y should be 1. Okay. And my new x and new y not in visited, which is a global one. So I'll say self.visited. Now I will add it self.visited, add it new x comma new y. Okay, and in this case I'm pushing them into an array new x comma new y. So these are like just the value changes, because in place of a normal graph, in place of an adjacency list, this is a grid. So I'm just converting it into 2 dimensions. Okay, anything else which we should do? So graph, because I'm passing it here, so I'm able to use it. Did I miss something? So xy I'm passing, q dot append, then visited, we populated first, number of nodes in that particular one when increased every time. Even if one cell is there, it will simply come here and do this addition and nothing will happen because there will be no neighbor, a valid neighbor, I would say. All right, so this should give me everything. Okay, let's just try if there is no compile time error we left. Okay, invalid. Okay, if yeah, so this block is inside. In fact, I can move this line and add it here and this. Now I do not need indentation. Shift tab. Oh yeah, for this if I need. Okay, we'll run it again. Oh, okay, yeah, so I used row and column, so I can define it if I want. So it can be a global one, but for simplicity I'll simply define that whatever is my graph, which is a grid, so length of my graph, and column will be length of graph's first row. Is this column or columns and rows plural? Okay, so one mistake which we are doing is actually very basic one, that we are not even checking if the root node is actually a valid land or water, right? So one more check we can do here. If this is not visited, we already did, and though that should be first, and like we said that this particular thing is actually land. So yeah, no harm in adding it here. So I'll say graph, which is this one, and x comma y is 1. Then only we need to go forward. Okay, so looks like, yeah, basic we are able to do. Let me hit submit, and ta-da. So yeah, we just applied that algorithm. We didn't change. That is why I'm not even trying to optimize for space complexity for this particular question. I'm trying to apply the template. Right now we'll calculate space complexity and time complexity in context of this question, and we'll see for this particular question what better we can do. All right, let's calculate the time complexity and space complexity of the code which we did. Before we do that, let's do the time complexity of our generic BFS algorithm. And this is a little bit, I would say, tricky, because if you are used to doing time complexity, normally people think of that because we are having two loops. One is this while loop, and inside which we are having this for loop, right? Then the time complexity appears like it can be n square if number of nodes in this particular graph are n, right? But that's not the case. Let's try to see how we can compute the time complexity. So overall, if we are having a graph, think of a graph like this. I created it like a tree just to explain it for simplicity. So if you are having a graph, what are we doing in this particular for loop? Everything inside this for loop is like every line is constant, right? Means order of 1, so that no need to discuss it that much. But this loop, how many times this loop will run, that is one time complexity. So what we are doing here is, for every node, like if we are taking this B node, right, for this node, how many times you will run this loop? Actually, you will run it number of neighbors you are having of B, right? So in this case, these two neighbors. So you will run it these 2 times. Same way it will happen for every node. So it is not like for B, which we got in our node, we are not running it in worst case scenario also for all other nodes into the graph. We are only running for its neighbors. Okay. So if we are only running it for neighbors, that means overall, this will run total number of times how many vertices we are having in our graph. So this for loop overall will run only V times. So order of V is the time complexity of this for loop. Plus so number of vertices, I would say, is the time complexity of the while loop which we are running, because we are pushing every node into our queue only once, right? That is the check we are doing here. If not visited, that means if this is not in the queue, then only we are adding it into the queue. That means overall number of elements which will be pushed into the queue and popped out from the queue is number of vertices. So that is number of order of V. Now for every V, like I said, it will only run for neighbors. Neighbors is nothing but how many edges it is having, the B. And that will be that for B, it will be 2 times. You can also say for parent also, but we have a check. So whatever is inside this loop, that is not going to be executed for the parent edge, right? So overall, for this particular for loop will run number of edges times. So that is why we are doing it addition. So whatever is total number of edges in the graph, in my entire graph, it is not like for every vertex it will run for every edge. It is only running for edges which are for that particular vertex. So that means overall number of edges which we are having, that is the total summation it will be. Hence the time complexity of this entire method, which is my BFS method, will be V plus E. This is not straightforward to see because there is a loop inside loop, and whenever this is happening, normally people come to the conclusion like it is V into E or V into V, like V square, right? But that's not the case. So this is the time complexity of our, you can say time complexity of BFS. What about space complexity? Space complexity is, in this method, it is pretty straightforward. We are only taking we are actually taking 2 supporting data structure for us in this algorithm. One is Q. So for Q, we are pushing all the vertex one time, right? Though it is not possible that all the vertex can be there into the queue at one time, right? Because you will pop and only one level can go in the graph only one level can be there in the queue at one position. So but worst case scenario, you can say if one node is connected to every other node, right, in the graph, means if I'm having only 2 levels, then you almost n-1 will be pushed into the queue at one time. So for queue, I'm actually saving all my elements. So order of n is the space complexity for this queue. For visited also, because I will add everything into my set, so again it is same, order of n or order of v, I would say. For both, it's not n, it's v actually. So order of v is the space complexity, so it is 2v, so in big O term it will be order of v is my space complexity, and time complexity we already did, which is order of v plus e. That is for BFS. Now coming back to our code which we just did. In this one, first thing is we are having this BFS method which is identical to our basic template. So the time complexity will be same, which is my v plus e, where v is how many vertex we are having, whatever our number of cells we are having in our grid. Okay, and number of cells, how many number of cells are there are actually m into n are the number of cells we are having, plus edges is you can say 4 into m into n. So that so overall it will be order of m into n will be my time complexity, and you are doing addition, so it will again come back to the same thing. Now but how many times we are calling this method? We are calling this method for every cell, we will call it once, and that's it, because if this is visited, we are not even going inside it. So whatever is the time complexity of this loop is nothing but m into n. So m into n is the overall time complexity of this, and whatever is happening inside it is actually linear. So m into n is the overall time complexity of this particular question as well when it comes to time. But space wise what we are doing is we are again using the queue which we calculated, that we will push in worst case scenario every cell once. So m into n again is my space complexity for queue. We are using set as well, where we are pushing every cell again. This space we can easily save if we just manipulate the same grid, right? I didn't do it intentionally because I was focusing on how we will apply the BFS, the same template which we created for ourselves, in place of doing any optimization. But here optimization is pretty simple. If I just modify the same grid, so whenever I'm visiting it, I can mark it as 2 in place of pushing it into the visited set. If I'll do it, then I do not need any separate visited set or array, right? I can reuse my grid via just changing the number. So that can be the you can say space optimization we can do in this particular question. But that's not the intent. I'm not looking for optimization right now. I'm looking to practice all the questions, but we should be knowing what we are trying to achieve here. That's it in this one. Now let's move forward. Now let's jump to the second question. This is very similar. In last one, we did that which one is the biggest island. That I would still say is more complicated compared to this one, where we just need to calculate how many islands are there, right? So question is same, that 1 is your land and 0 is water, and around the matrix everything is water. So you just need to calculate how many islands are there. So if I go back to the same matrix which was given in this question, so here earlier we were returning the number of ones we had in one connected island. This time we just simply need to mark them as visited, which we were doing earlier also, and we just need to return, right? Nothing else is required, because if you will just return also, you just, so from here I will simply say if this is 1, right, and it's not visited yet, then let's do a BFS into this particular island, which that means it will mark everything as visited till wherever it can go, and just return back. You don't need to return anything. Also, when you are doing it, you just need to do a +1 in your answer. So that means one more island I have visited. So I do not even need to return this number anymore. Okay, so this small change is actually good enough. So I don't, like I said, this number I'll remove from here. I don't need to do any of this. It's just that I need to mark them as visited, so that I'm not going again and again into a visited island. So if I copy paste the same code in number of island as well, so indentation wise everything looks fine. I'll call the BFS code from here, and that is also 4 directional. So I'm just reusing the same code, no change. By default number of islands are 0 whenever it is going inside the grid. If this is not visited, then I will simply do +1, that this is the new island which I kind of found. So let me check if there is no compile time issues. By default it is returning as zero. Okay, let's just see what happened here. So first we are having this visited set, answer is 0 for my grid, which is this. Okay, got that. So here grid is nothing but having, this is a string array. Last time we had an integer array given, so that is where the comparison is not correct. So I'll do compare the value like this, and same thing should happen here as well. If this is 1, that's the valid case for us. Yep. So one more, I think I'm doing some addition. Okay, yeah, I'm returning a number which is not required. I don't need to return anything in this case. Perfect, looks like it's fine. Let me just submit it, and it's done. Yeah, so there was nothing at all, right? We just use the same code and we are done. Here also we can do the same improvement again, that we can reduce the time complexity if we can reuse our grid, right? So that we can do. I'll leave it on you when you are implementing this particular question. You can better this. You don't actually need visited array when you are having a grid, because you can manipulate the grid itself. You can manipulate the values here. Cool. All right, let's do the next one. So number of provinces is same as number of islands. It's just that the graph is given in a different format this time. So it is saying that is connected matrix is given, which means that if for this first row 1 is connected to first column, means one node is connected to 1, which is, you can ignore. 1 is connected to 2, so there is an edge between 1 and 2. And same way, if you will make a graph, ultimately it will be it will look like this, right? So if this graph is given, we just need to tell how many components are there. So this is same as number of islands. What we did in number of islands, we actually checked if they are these cells were connected. So we did a BFS on this once, and it gave me that this was 1, and how many times we did BFS overall on on every component, and that was our final answer. Same way, now I need to do similar thing. It's just that graph is given in form of this we call adjacency matrix. This is not a list, but adjacency matrix, where you are given with that particular node is connected with how many other nodes. So in a Boolean format, you can say it is given. So I copy pasted same BFS. We will tweak it for this particular question. First thing first, now my visited set, you can say, is this is a different way of writing our visited set. In place of set, this time I'll use an array. So I'm having number of nodes here, 1 2 3, right? So I'll simply use that n, one array of everything marked as false by default, and n is nothing but length of this matrix. These are you can say my number of total nodes are there. So length of is connected graph is my n, and matrix, like the said, is n into n, so it's same, right? Now next thing I need to do is answer is by default 0. I just need to do for I in range of my n. That means for every node, if that node is not visited, that means my self.visitd of that I is false, right? If this is false, I will simply add if not this, right? And what else I need to, that's it. If this is not done, then I will simply call a BFS where I will do the BFS for this particular node. And because I'm not using my graph as global, so I'll pass a graph. Normally we should keep these as global variables and do not pass it into recursive method, but here I'll ignore that level of low level details, because I'm focusing only on algorithm. Visited, I don't need to pass that. I marked as global one. Every time I'm doing it, I just simply need to increase my count of component, and that will be my answer. Now what are the changes in queue? Now because it is not sending me two things, it is sending me a node, so I'll call it a node. In queue, I will append that node, and in my visited, because it's an array now, in visited for that particular node, I will mark it as true. True means this is visited. Now from my queue, I will get one number. I don't need to do anything for that number. It's just that I need to explore the neighbors of it. So I'll say index in range of, for that particular node, I think that's it. So in though all are n, but you can say in that particular node, whatever number of elements I'm having, that number of times I'm running this loop. The only change is that I need to check who are the neighbors of it. All right. So first thing first, I'll say in in place of node, let's call it u. Whenever node was given as a start to me, now this is u, and from u I'm going to every v. So let's call it v. So in u row, whether u and v are connected first thing. And if my V, which is the child, is not already visited and not visited, in that case I will first mark it as visited. Self.v is equals to true, done, and then I will add v in my queue. I think that is the only change I need to do in BFS, and this should be done. Compile time, so length of graph I'm receiving it. What's wrong? Okay, I need to close this process. It looks like it's working for basic cases. Let's just run it, and yeah, it works. So yeah, perfect. So this was the third question which we did with BFS. These were obviously the easy questions, but we wanted to do breadth first search as one of our traversal, and we wanted to try questions where traversal is good enough for us to give the answer. I think that's it. We will cover in BFS, and now obviously once we master it, follow-up categories, that is where we will need all these traversal again and again. So we will be able to master it when we'll do tough questions. Thank you. Have a good day.